the minus sign.
Okay, so like,
Don't forget to set this equal to 0 as well, right? That's one of your factors. So plus or minus 6 is right. But then look at my steps. Do you see how so I've got my factoring here. Do you see how I have that as part of my factors, and I also set that equal to 0?
Okay.
Set all of your factors that have variables equal to 0. That'll get you there.
would you count an answer wrong if it wasn't fully reduced?
If it was what?
Wasn't fully reduced.
Oh, you're talking about the 36/15ths versus 12/5ths thing? I don't know.
Okay.
In this case, probably not, because it just said solve for x. But if it said, write your answer in most simple form or something, well then, yeah, because it's what the instruction says. So. It is kind of a weird one, right? You look at it, it's even and odd, and it's like a 3. Okay, ladies and gentlemen, here's a chance for you to ask questions. Hey, hush. Is there anything I can help you with on number 1? Number 1, the answer was 12/5 as far as a fully reduced answer. 36/15 is also a correct value. It would make this equation true. So I put all that in the box there. Any questions on 1? Remember, next week, Tuesday, quiz on this.
I don't understand how you got a positive.
Next Tuesday?
A positive what?
Yes, that's the answer is positive. I got negative 12.
So let's look at our steps. We should, if we both showed good steps, we should be able to kind of trace it through and see where the discrepancy is. Did you distribute the same way I did in that first step, the red step? 3x minus 33 plus 6 equals 9 minus 12x? Okay. So I did this. I went ahead and added my like terms on the left side. I said negative 33 plus 6 was minus 27.
Okay.
Did you do the same thing?
No.
What did you do?
I subtracted the 6 first and then distributed it.
Okay, so you had 3 times x minus 11
Yeah.
equals 3 minus 12x. You have that exactly?
Yeah.
So then we distribute. Still good?
Yes.
Okay, what'd you do next?
I added the 7.
Okay, so you got 3x equals 36 minus 12x.
Yeah.
What came next?
I added 12 over.
Okay, so if I add 12 over, plus 12x, plus 12x, that gives me 15x equals 36.
Yep.
How'd you get a negative out of that? Sounds like we, look over your steps. Sounds like we, because obviously the last step is just divided by 15, right?
Yeah.
So it sounds like we agree on a lot of, pretty much all the steps. Trevor, let me know if there's anything I can do to help, but I think you kind of talked yourself into it, right? Okay. How about number 2?
Could you do number 2 for me?
Sure. So I'm just gonna leave this first step up there, and Bray and perhaps others. I want you all to, just with an honest eye, here's at the core. Here's what we need to do. We need to address misconceptions. Basically, misconceptions are, I thought it should be this, but now you're telling me it's that. What's the issue, right? So look at my first line. I've got 100, x to the negative 8, y to the 14, 5 to the negative 2, x to the negative 12, y to the negative 2. Are there any of those that when you look at your work or you think about it, you disagree with, or you think, I thought it should have been this, and now you're telling me it's that? Yes?
Okay, so on the right side,
Yep.
it's 5 to the negative 2.
Yep.
And then x, blah, blah, blah. But then on the left side, it's 100.
Yep.
Like you already squared it with the 2.
I went ahead because 10 squared is 100.
Okay.
Right? Like, we could, if you wanted, to be very consistent, we could, what's the deal? Sorry, all of a sudden my pen's not working. We could write, instead of 100, we could write 10 squared. I personally don't feel like we have to do it that way, but we can. So I'm going to write 10 squared. So are we in complete agreement now?
Yeah.
Okay. So let me write a little bit more. I would say next I'll write 10 squared x to the negative 20 y to the 12 times 5 to the negative 2.
Why don't you add the 2, the 10 to the second, and the 5 to the negative 2?
Because they're different bases. Remember that thing we just talked about?
Yeah.
Great question. So if it was 5 to the 2 and 5 to the negative 2, well, we could do that. Or if they were both 10 bases, we could do that. Again, all you're doing is you're saying, I thought it should be this, but you're telling me it's that. What's the problem, right? It's at the core. That's what we're trying to do here. Just give you another moment to think. Okay, so then I'll show you another step. I'm thinking the next thing I would do is write 10 squared y to the 12 over 5 squared x to the 20. Again, so were you going to say, I was expecting you to do this, but you just did this other thing? Why? Please ask. Who knew? Having a conversation is the way to get good at math.
To learn.
Yes. I think most people think math is done without words. I think having a conversation is key. So nobody's questioning that, right? Nobody's saying, why did you flip this there? And why is this such and such? I'm not going to get mad. I'm not going to cry. Nothing like that. Just want to know what you're thinking. I'll tell you what I'm thinking. All right. So then my final couple of steps would look like this. Finally, I'd get to the point where I'd say all my exponents are positive. All my exponents are positive, so no more flipping anywhere. I'm just going to simplify all that I can. I know that 10 times 10 is 100. And I know that 5 times 5 is 25. And then my last step would be to recognize that 100 divided into 25 equal parts. How many parts do I get? 4. Yes. So it would be 4 y to the 12 over x to the 20. I know that I'm all done because all my y's are together, all my x's are together, all my numerical bases have been completely simplified and reduced and all that good stuff. There's nothing else I can do. All the exponents are positive. I'm done. Okay, so there's number 2. What about number 3 or number 4? Either one. Mason.
Yeah.
Let's not use that for that. Great.
Question about number 4.
Sure.
Would it be the same thing if it was x equals plus or minus 6?
Yes. Yeah, so that's a great way to write it. Noticed quite a few of you did. You wrote x equals 0 and x equals plus or minus 6.
Same thing.
Same thing. Absolutely.
So
Anya.
factoring is the best way to do that problem then?
Well, I think that it is a good way. Can I present an alternative?
Yes.
So factoring works great. Or, and I use the difference of squares. I did, right here I used the difference of squares. Or you could do this. You'd have to use some factoring, but you could do this. Like the first step looks exactly the same. But what I could do is I could set each of these factors equal to 0. And then this would give me x equals 0. And check this out. This is using a newer skill, but good math is good math, right? What would I do now to get the x all by itself?
Square root.
Whenever you square root both sides, what do you have to do? There you go. Bam, same answer. So either one of those is perfectly acceptable. The only issue would be is if number 4 said use factoring to solve. Then we get into a little bit of gray area, but technically the red did use some factoring, didn't it? So I come back to, hey, good math is good math. If you know what you're doing, it's going to work out fine. So, yeah, I'm good with that. Anyone else with a question? Alrighty, so I can just be coming around checking with a few folks for the next 10, 12 minutes, like we did last time. I want you guys to be working on review work, whether that be WebAssign or stuff out of your packet. Caroline, hold that thought, please. Whatever it might be, and we'll do some quiz retries here in like roughly 10 minutes or so. If you don't need to be doing retries because you've already done them or whatever, then you got the next 25 minutes or so to be reviewing and getting ready.